Okay, welcome to this video on how to make diagrams in Latex using tikz. So this is quite a fun way to make diagrams, and it makes diagrams that look really nice, really look like textbook diagrams. Does take a bit of time in the beginning, but obviously most of our work is all on sort of the same stuff. So once you've got one or two diagrams going, after that it's a copy paste and just editing here and there. So the first one or two take quite long, and after that it really speeds up. So what I'm going to try and do is I'm going to recreate one of the diagrams in the engineering vibration textbook by Daniel Inman. And yeah, so what I've got here currently is just a, let me hide some of this. So we've got a document class, article, as always, use package tikz. So tikz is the package that we need to draw the diagrams, begin document, end document, and a figure over here. Now I've hidden some stuff here because I forgot what these commands are, so when we need them I'll unhide them there. But then within this figure, usually we could put in include graphics to put like an image of something or so on. But what we've got here is a begin text picture, so hopefully the centering and the caption you are familiar with. But then we've got the begin text picture, end text picture, and then in there we've got some draw commands. Now these draw commands are kind of like Simon Says kind of things. So it's like draw a circle at 0, 0, and it has radius 1. So that's what that means. And then we've got these semicolons here to indicate end of line. So that's what I've got over here. So I've got a circle with a radius 1, really simple. So we'll start off there. What I want to do is I want to draw a what does the diagram in the textbook say? A single spring mass system for free vibration. So we need a fixed wall, we need a spring, and we need a mass, and then we want to label that mass M. Okay, so what I'll do is I'll start with a fixed wall on the left hand side. So let's draw a rectangle. You're going to have to forgive me if I edit this video a lot because my tikz syntax is not on fire, and I might need to check here and there for what the syntax is. But okay, let's start with a rectangle. And basically what this says is we go from 0, 0 bottom left corner to 2, 2 top right corner. Now I probably don't want 2, 2. Let's make it so 1 in the X, 2 in the Z. Sorry, Y. And then okay, let me draw that and show you what that looks like. That should just be a rectangle as we expect. Cool. Okay, that's probably a bit wide, but anyway, let's go 0.8. Okay, but that is not just a plain rectangle, and what we want is we want it to look like a fixed wall. So what I'm going to do here is I'm going to unhide this comment. Now there's decorations, path morphing, patterns, and arrows. So right now what I need is a pattern. So I'm going to use if you check on the left hand side, it says use tikz library, and then it's got patterns. So we need a pattern. The decorations, path morphing, and the arrows will come into play just now. And again, I also don't remember these. Whenever I want to do something new and it doesn't work, I just Google or ask one of the chatbots online, and it works. So don't get too worried about that. So what I'm going to put in here is I'm going to say pattern equals north northeast, I think. Let's see if that throws an error for me. So northeast lines. There we go. Okay, so there we go. Now, because I've gone and put in the pattern, you can see that this looks like a fixed wall, but perhaps we don't want the sort of outline on there, so then we can just say draw equals white. So this means that the border that it draws is going to be white, I think. There we go. So there we've got a fixed wall shown as hatching. We probably want to also draw a thick line from, let's say, 0.8 comma 0. I'll explain this now. When you see it, it'll make all these sense. To 0.82. So basically we just want a thick line at the right hand side representing the wall over here. There we go. Now I've got a fixed wall, and that's all cool. So again, this took a while to put these two in and to figure out where they go. But once you've got one fixed wall, every other time you want a fixed wall, you just copy paste the same code, and it goes really quick. Okay, now we want to put in a spring. So probably from the middle of the fixed wall, we want to put a spring going to the right. So let's call this spring. We say this is fixed wall. Oh, okay. So now for the spring, we draw a line as well, and except the only difference is we decorate that line with a zigzag, and that is why this decorations comes in. So what we'll do is we'll draw, and then we'll say decoration equals zigzag. And then there's some options that we can put there, and it's already pretty good. So I've got GitHub Copilot in my editor, which is quite nice. So it predicts that we want to go from 0.8, which is the right side of the wall, 1, which is the middle of the wall, and then we probably want to go a bit further than just the wall, so we want to go to 2. So let's see what that looks like. Okay, we are getting an error. Okay, so I had a little error there in my code, but as you can see now that I've sorted that out, we've got a spring coming from the wall. Now it's perhaps a bit too short, so we'll make this go to 4.5, or let's just make it 5, so that for the rest of the time everything else makes sense as well. Okay, so there we go. We've got a fixed wall, and we've got a spring represented by a zigzag. Now there are some options that you can put in to make these zigs bigger and so on, but for use of this tutorial I think this is fine. And then we want to put in our mass. Now our mass will be a rectangle as well, so I'm just going to copy this rectangle code down here. I'm going to remove the pattern, and I don't want it to be white, I want it to be black, so I can just leave that as normal. And then we probably want this to go from the end of the spring, which is 5, and 0, which is the ground, to, let's say, 7, so make it by 2. Okay, and then that'll be the mass. So if that all works out, we should have a mass on the right hand side. Perfect. Cool. Now I would like a ground along the bottom here, so let's quickly go and do that. Just draw a line representing the ground. Ground below mass. These are just comments I'm putting in here. So then let's draw again, and this time we want a line, so we want it to go from, let's say, 2 before the mass, so that's 3, 0, and we want this to go to 2 after the mass, which is 7, 8, 9, 0 again. Don't forget that semicolon. So now we should be getting a line below the mass there. Perfect. Cool. Okay, now we've got the mass, the ground below the mass. I would like to put a label for the mass. So what I'm going to do here is I'm going to after the ground, I'm going to say labels, and then I want to do the mass. Okay, so this thing is doing the spring, but I'm happy with changing this to mass now. So we create a node for where we want this label. So we want this node to be right in the middle here. So this is now at 5, and this is at 7, and this is 0, and this is 2. So the middle will be 6, 1. So we want this to be at 6, 1, and we call that mass. So that works out. We should have an M appear right in the middle there. Cool. Alright, then we also want to do the spring. Now the spring goes from 0x to 5, so we probably want it in the middle, so that's about 2.5, and then the spring is at 1 height, so we probably want to make that 1.5. So let me just put a label, a comment there, and then we say node at, and this time I said it wants to be, I wanted at 2.5 and 1.5 to make sure it's high enough, and then we call this spring constant cool. So as you can see, GitHub Copilot is doing a pretty good job here. And there we go, we've got a spring. For some reason that feels too far left to me. I don't know why that is. So I'm just going to change this to 3. See if that doesn't sort it out. Now that feels better. How come? 5, 0. Sheesh, that's interesting. Okay. What I would like to do now is just maybe add a datum line over here to show that maybe this is the rest position. So we add a line here and then an arrow going to the right, showing that maybe that's the sort of positive X direction, and then we can put an arrow, and then I can show you how arrows work. So that means above the mass, probably just want to leave a gap, and then we'll draw a vertical line, maybe 1 long. So call this reference labels, or reference, yeah, let's leave it as points. So this one we want to draw a line, so that's just draw, and then we want to go from 6, which is the middle of the mass, and the height we want to make it, let's say 2.5, so we leave a 0.5 gap above the mass, and then we want that to go to again 6, so X stays the same, and here we probably want to go to about 3.5, make it 1 long. Okay, so I hope these numbers are making sense to you. If this is 2, we want to be at 2.5, which is just above 2, and we want to go to 3.5, which is 1, and the X from this point here is 6, which is at that point. All right. Now from the middle of this, we want to draw an arrow to the right, and we want to label that X. So let's just call this rest position. So then we want to draw in the arrow. Now to draw the arrow, we say draw, and then an option that we put here is we put an arrow, which means we basically want this to be an arrow. So we'll go from 6, which is the start, which is this line over here. This is at 6, and then its height is halfway between the 2.5 at the start of that line and the 3.5 at the end of that line, so that should be 3, and then we'll make this go to, we wanted to go across, let's say 1, so that'll be 7, and we keep it at 3, so that's a perfectly horizontal line, arrow, sorry, and we'll call this, sorry, let me sort that out, and we'll call this positive direction. Okay. Oh, man. Alright, so there we go. Now you can see we've got a little arrow pointing to the right. Now I told you about this arrows at the top here. So this arrows, I think it should be .meta. This arrows.meta allows you to put in some cool other arrows. Once again, all this is online, so if you want better looking arrows or whatever, you can do that here. So I know that I like the stealth arrow, so if we look at what that arrow looks like, that's the default. It's sort of got these 2 little lines, and then if we make it the stealth arrow, if I didn't mess something up, I did. Okay, so the mistake that I made is the stealth is meant to be in a curly braces with a little line there. So effectively this line with the arrowhead, it should be this line with the stealth arrowhead. Okay, let's see if this works. There we go. So now you can see that that arrowhead is no longer just like those 2 lines, it's sort of a filled in arrowhead. Okay, and then we can now add a label to this X, so we can say node at We probably want it about halfway down the arrow, so we call it 6. Oh no, we want it to the right of the arrow, so let's call it 7.3-ish, and we want that to be at 3. Ooh, at 3, and then we call that X, yes, positive direction label. Okay, so now we should have an X somewhere over here indicating that that's the positive direction. Cool. So yeah, you can set up free body diagrams and things for this as well. So we could go and remove the spring and just put an arrow on the one side. Maybe let's do that. So I'll show you how quickly we can sort of manipulate images once we've got something like this. So let's say we want a second figure that shows a free body diagram of what's going on here. Okay, so what I quickly did is I just went and included the use package subcaption, so that allows us to use subfigures. I then went and said within my main figure over here, I went and said, okay, begin subfigure, and I want that 0.45 text width, so you always need to do that with a subfigure. I then ended that subfigure, then started a new one which I also want 0.45 text width, ended that, and then there's a caption for them both. And then within the first one we've got the text picture that we just drew, and then with the second one we've got an empty text picture. So I hope that's clear. Let me open uncollapse or whatever you want to call it, all of these, so that you can just see where we are at. Okay, so because we want to do a free body diagram, I want to have my mass in there, so let's copy the mass down. And I think this is really the power of setting up text pictures. Once you've got once you've got your first drawing or your first couple of drawings, after that everything else just sort of falls into place. I also want to draw a force of the spring, but I don't want it to be oh, that's the wrong one. So where's my spring? So I want the force of the spring, but I don't want it to be decorated, so I just copy that down, and then I just remove the decoration option here. Okay, so now I've got the spring in place, just as a line, but I would like that to be a stealth arrow, and this time I put the sort of the sort of body on the arrow on the right hand side to indicate that it needs to go left. I think we'll check when I run that. So I've got my mouse and I've got my arrow, and then let's just assume there was a force pointing to the right hand side. That force would probably be in the same direction as what this X would be. Now again, this X arrow that we've got over here is above the mass, and not over here where we'd want it. But we can just put this in here, and then what we'll do is we just edit these coordinates. So I'll leave them there for now, and then we'll probably want let's say a normal force. So again, we can just draw a line here, indicate that we want an arrow, we want it to be stealth, and then we call this normal force. Let's call this force direction, I guess, and then we call this the spring force. Okay, so I'm going to build this, and it's not going to look like much, but just so that you can sort of see where we're at. If nothing breaks, nope, nothing did break. Okay, so you can see we've got two figures next to each other over here, and they sort of overlapping and whatever. But what we've got is this arrow over here. This is the arrow here. We've got another arrow here, which I said I want to use as the normal force. I'll probably just use this as the force and then use this as the normal force, and then we've got our spring force in place over here, which you can see going all the way to the left. Okay, now also what we can see is that this first image is way too large. It's taking up more than its sort of space that we've allocated to it. So a nice thing that you can do in tikz is you can just scale your image by 0.6 or whatever we want to do it. Now this will make them different sizes, but again, I'm not putting too much foresight or forethought into this video. When you're doing it, you can just play around with it. Okay, so you can see that's much smaller now, and that took literally one command. Okay, so let me change this around to be the normal force, and then we call this the force, and then just remove that. Okay, So the normal force was correct on the left hand side, so I'll copy that over here. And then what we wanted to do is probably go 5, so we'll make that go to the right 2. You know, let's just make that 4. That was incorrect. The force was correct, so this value was correct, 7.1, and then what we want to do is we probably want to make it go to, let's say, 8.1. Okay, so that should have now taken this arrow and just moved it across 1. There we go. So now you can see it's on the right hand side and it's pulling across. Next, let's just shorten this arrow, which is pointing to the left. As you can see, the arrowhead is to the left because the stealth represents the arrowhead and this represents the body. So because the body is on the right hand side, it points to the left. Now this side is correct. The 5.1 is correct because that is at 5.1. So what we can then do is we can just change this to maybe 4 instead of 5. So this should now only go to about here. Okay, there we go. To the left, to the right, and now we just need to change this normal force to point upwards. So the normal force needs to be at, I think midway was 6, so these both need to be 6, and then this needs to go from let's say -1 to 0. So -1 will be probably down here and 0 is on that bottom, and there we go. Now we've got this going from -1 to 0, which is the bottom. We've got the force from the spring, we've got a forcing function, and then we've got the normal force. So maybe let me put this forcing function in here and label it F, and then we can also label all of these on the free body diagram. So force, I can just copy straight back here, and then we can, let me move these labels to below this, just makes more sense in my head. And then we say node at, and then you see this is kind of figured out that it needs to be a vector called F. In this case it doesn't need to be a vector because it's only one, so we'll just call that F, and it needs to be at 1.51. We'll see if that works. No, so it's going to put F over here. We want F over here, but that's an easy fix. We can see that our force ends at 8.1, which means we probably want this at, let's say, 8.51, argument's sake. So that should put it over here somewhere. So this F should move, and there we go. Now I've got off F. So this arrow here should be our spring constant, which should be K delta X. So we can add this to our second figure. So we can say draw, node at, and then the spring force should probably be at, let's say, 3.51. So 3.5 is just to the left of this first arrow. So this is 3, this is 4, so 3. Sorry, this is 4, this is 5, so 3.5 should be about here. 3.51, and then we can call this F. So this F, let's say underscore K to represent spring, is equals to, and then we can say simple Kx. So F is Kx. Let's test if that worked. So we're expecting F equals Kx over here. Cool. Now you can see that these overlap. That's because I've got my node at the wrong place, so it's going to overlap. So maybe let's just move this up a little bit. So instead of being at 1, we called 1.5. There we go. F is Kx. Probably 1.5 is probably too much. 1.3. Okay. Next, we can probably label the normal force. So Copilot's gone and figure that out for us. I prefer a capital N. So 6 is halfway on the mass, and then we probably want it probably down here somewhere. So maybe 6 point something, and then just below -1. So let's make it minus 1.3 and 6.3. There we go, normal force. Oh, we probably want to put mass in the middle there. So this again we can just copy from the one above. It's going to stay exactly the same. Mass, spring, normal force, and then we can have a force label. Keyed up Copilot doing its thing again. Fantastic. Let's see if it made a good choice. So we expect the mass and the force to be put in place. And perfect. Now we've got a free body diagram of our actual diagram on the left hand side. So that wasn't too long. Maybe let me just make these images captions a bit better. Okay, so what I want to do is under the first text picture I want to call this let's just say full diagram, and then after this second text picture I want to call this free body diagram. Oh, man. And this should now put these two with AB. Perfect. So now it's going to label that as expected. So obviously you can see there's an unbalanced force here. The Fn is going to push this thing up to infinity. We're getting an mg. So let me take away the mass and call it mg. So we'll say mg. By the way, you can use c dot to put a dot between those two. You'll see what that looks like now. Let's move this slightly over to the side. So we'll say 6.3 again. And then let me add an arrow here for gravity. So we'll draw, excuse me, we'll draw another stealth arrow. And we'll make this go from the center of the block, which should be 6.1, and we'll make this go down a little bit. Oh, what am I doing? We then want this to probably go 6 to 0.3, for example. And we'll call this gravity direction. There we go. So effectively I just want that to go down to about here near the M. Okay, and you see that C dot went and put a dot between the M and the G, which in this case is actually making it look bad. So let's just make it mg as we would write it. There we go. I actually think it would be nice to have these two forces touching each other. That actually makes a lot of sense. So we just change this arrow to, instead of going to 0.3, we make it go to 0. Hopefully all these numbers that I keep mentioning make sense to you. Just with each image has its own sort of reference, and that reference can kind of move around. So in this case 0 was over here, sorry, 0 was over here, and everything moved forwards and backwards according to that 0. In this one, 0 again is somewhere back here, and we're dealing with these 5 to 6 and whatever, so it's all kind of relative, and you should make sure you're happy with which relative you're dealing with. Now there's lots of other options. Maybe I'll make a video on how to do graphs in tikz, but there's lots of other options that you can do. So this is just a beginning, a little example, but as you can see, if you wanted to make an image with a 2 degree of freedom system with some masses, you would literally just go and copy the code from this spring and this mass and this x direction, paste it, add 2 or 3 or something to each of the x values, and there you've got another image, and it took you 20 seconds. So even though initially it takes a while, after you've got a couple of base images set up, it's really quick.